Assalamualaikum warahmatullahi wabarakatuh. My name is Ifa Fikri bin Izzah, my metric number 170840, and my group will answer the question 27 from class assignment 2. And here is the question. We can model some of the electrical properties of an unmyelinated accent as an electric cable covered with defective insulation so that current leaks out of the accent to the surrounding fluid. We assume the accent consists of a cylindrical membrane filled with conducting fluid. A current of ions can travel along the accent in this fluid and can also leak out through the membrane. The inner radius of the cylinder is 5.0 micrometer. The membrane thickness is 8 nanometer. And there is three parts of the question: A, B, and C. In question A, it asks about the question is, if the resistivity of the accent fluid is 2 ohm meter, calculate the resistance of a 1 centimeter length of accent to allow current flow along its length. And in B, if the resistivity of the porous membrane is 2.5 exponent 7 ohm meter, calculate the resistance of the wall membrane of a 1 centimeter length of accent to allow current flow across the membrane. And in part C, find the length of accent for which the two resistance are equal. This length is a rough measure of the distance a signal can travel without amplification. And each member of us will explain each part of the question, and the information we have highlighted in this question will be extracted into each part that need the information.
My name is Shahrin, metric number 170929, and right now I will answer the question part A from question 27 in class assignment team 2. So from the question part A, it is asked what is the resistance of the axon fluid, which the given of information is resistivity of 2 ohms meter, the length of 1 centimeter, and the radius of 5 micrometer. So this is how I answer the question. First of all, we have to understood the question, what does it need and how we can overcome it. And obviously the second step is to extract all information given from the question. Then what I do is to convert all the info to SI unit, and thirdly find the suitable formula to solve the question, and lastly just substitute all info into the formula that we have decided. So for the info, this is what the info given from the question part A. The resistivity is 2 ohm meter, and the length is 1 centimeter, and the radius is 5 micrometer. To the second step, I will convert all of the information given to the SI unit, and from these three, I only convert the length, which is centimeter, to meter, and I will get 0.01 meter. And my third step, from all of my analysis to the topic, this is what I come out with: the formula of R equals to permittivity times length over A. And we know that we don't have A, and the only way to find A is by pi r square, since the axon fluid is in the shape of circle. So substitute all the information given to the formula, and the final answer will be 2.55 to the exponent of 8 ohm. That's all.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ifa Fikri, and I'm going to explain part B in question 27. And in part B, it asks us to calculate the resistance of the wall of a 1 centimeter length of accent to allow the current flow across the membrane, and the given information is the resistivity of the porous membrane. And here is how I will describe the question. We want to calculate the we want to calculate the resistance of the wall of this wall to allow current flow across this membrane. And the wall, we assume that the height of the wall is the length of the axon, and this is the radius for the axon. And here is how I will answer the question. Like Lokman said, there is 4 steps, and the first step is extracting the info. And the info that were given in the question, first is the resistivity of the porous membranes, which is 2.5 times 2.5 exponent 7. And here we have the length, which is the length of the thickness of the membrane, which is 8 nanometer. And we have the radius of the axon, which is 5 micrometer, and the height that I have described, which is 1 centimeter. Next, we convert them into meter, which we have to convert the length, radius, and the height, which will be 8 exponent negative 9. The radius will be 5 exponent negative 6 meter, and the height will be 0.01 meter. And the formula that we have come up with is the resistance, which is resistance equals to resistivity times length over area. And in this case, the area of the cylinder is pi r h. And then we just substitute the value into the formula, which will be resistance equals to 2.5 exponent 7 times 8 exponent negative 9 over 2 pi 5 exponent negative 6 times 0.01, and we'll get the answer 6.37 exponent 5 ohm.
It's about question number 3. So the question asks, what is the length of the axon tube so that the resistance of the fluid inside the axon tube will be the same for the resistance in the membrane. So the basic information that is given is still the same, which internal radius is 5 micrometer and the thickness is 8 nanometer, and we are still using the same formula. Resistance equal to resistivity times length over area, and the resistivity is the same as given in the question before. So length of axon, which both resistance are the same, and for the solution is we just need to do R equal to R, which resistance of the both is the same, and substitute the formula resistivity times length over area for both sides. And in this case, we need to carefully choose what is x, or the length of the axon tube, as it will be different on each side of the formula. So for the first, 2x, 2 is the resistivity, x is the length of axon tube over pi r square, which is the area in the axon, equal to resistivity of the membranes and the thickness of the wall over 2 pi r, which is area of the membrane, and x is the length of the axon tube. And in this case, x take place on different part of the formula. First at the length, and second below, and second in the area, which is still the same value, the length of the axon tube. So by this formula we get x of x, or the length of axon tube, is 2.5 times 10 to the power of negative 7 meter, or 25 micrometer. Thank you.